Paul, take it away.
Oh, thank you very much. My name is Paul Roberts. I'm the editor at the Security Ledger, which is an independent computer security news website. I've done panels here at the Trusted Computing Group events in the past. I'm really excited to do today's panel, which is Will the Real TPM Please Stand Up? I don't think any of us are crazy about the title of this panel because it doesn't totally indicate what we're going to be talking about and where we're going to be going. But suffice to say, I think we're going to have a really wide-ranging and exciting and interesting conversation, both about the successes of Trusted Computing Group and the TPM, as well as challenges and new opportunities that are coming down the road. Without further ado, because we don't have that much time today, I'm going to introduce my fellow panelists here, and all of them are folks who have a deep history working with this technology and just kind of the security space in general. To my immediate left, I have Monty Wiseman, who's a security researcher at Intel Corp, and I'm going to let Monty tell you about himself.
Yeah, I represent Intel in several working groups in TCG, been involved in it since basically I was handed the first 3 documents in 2000 and said, go piece this together, and we called it TPM 1.1. So I do. I'm also the TXT and architects, work with the Intel architects for TPM technologies.
Great. To Monty's left is Dustin Ingalls, who's a program manager at Microsoft Corporation.
Yeah, thank you. So I work in the operating system security team, working on implementing different security features and technologies across, initially with Windows, but with the way we're kind of changing things now across all Windows-based technologies, including Windows Phone, Xbox, and other related technologies.
Great. So. Thanks, Dustin. And to Dustin's left is Shpantzer, who's an independent security consultant. Gal.
Hello. I've been in InfoSec for about 13 years now, and I do a lot of different types of work for CISOs who want to defend their network, vendors who want to get their stuff more secure, and tech vendors who need to deal with security assurance in order to get their products out there. So is this not loud enough? Can't hear me? Bueller? Anyone? There you go. Louder?
You need to talk like you're actually angry. That would be a good place emotionally.
I'm pretty chill, so that'll be hard, but okay. Can people hear me in the back now? Okay, thank you. So my name is Shpantzer. I've been in information security for about 13 years now, and I do consulting to all kinds of people, CISOs who want to defend their networks, and some vendors who want to get their products more secure. I ran into TCG several years ago and always been interested in it, but more recently in 2013, I did a paper for SANS Analayst activity with the TCG and some of the vendors involved, and learned a lot and understood that there's a lot more to it than just full disk encryption and other use cases. So pretty interesting stuff, all the way from cloud to virtualization to BYOD.
Great. Okay. I've been a reporter covering the security beat since 2002 and also an industry analyst. I've been writing about the Trusted Computing Group and the TPM, hardware-based root of trust, I think pretty much since the get-go. And I really have to say, I think we're really at an inflection point with this technology. It strikes me that it's never been more relevant than it is today, and that I've never heard more people kind of, people who I respect, security folks, talking about, it's kind of unprompted talking about TPM and implementing TPM. It used to be that you would bring it up and people would kind of go, so it strikes me that we're really at a very interesting time. Monty, I'm going to kind of toss the first question to you, which is, looking back on the last year and kind of what's happened in the last year, what do you think? What do you sort of see as the big accomplishments, or what is new and what's relevant in terms of this technology and both getting it adopted and used broadly?
Yeah, I think what's what's new is the understanding of what the differences between TPM 2.0 and 1.2, and the benefits that 2.0 is going to provide to the industry in the way of enabling this technology and enabling these platforms to attest to themselves. I think even though we released, I think we formally released the spec in 2013, there's some, we need to get out the message as far as like provisioning, enabling a software stack that TCG is working on, as well as Intel's working on. I can speak to that in the back if you like. But I think getting a robust software stack available outside of the Windows stack, which has a very robust stack all by itself. So I think those are the major accomplishments that we saw and that we're going to see going forward.
Yeah, I mean, you kind of gestured to Dustin. I mean, I think one of the most kind of visible. Yeah, sorry. It is a little bit of a softball, but then I'm going to start throwing at your head soon enough. One of the most visible kind of implementations of TPM would be Windows 8, right? And the various steps that Microsoft took between Windows 7 and Windows 8 to really bring TPM features and functionalities forward, make them easier to implement at the end user and also for the developer. But so there may be people in the audience who aren't totally aware of what that looks like in Windows 8 or what the changes are. So just talk about it briefly and because I think that's something that's worth noting.
Sure. So previous to Windows 8, the visible embracing of the TPM was really through BitLocker. That was the primary feature. There's an API set in there. There's other things, of course, that you can build on top of the TPM. But BitLocker was really the visible feature that we had. And as we really sat down during the Windows 8 planning process, a lot of things really became apparent. Our ability to continue to push the ball forward, relying only on software from a security perspective, we were at the end of the line. So, that's why you see there's a pretty pervasive change between Windows 7 and Windows 8 in terms of feature investments in TPM. We went from it's BitLocker and then you can build what you want to it's BitLocker. We laid down a TPM KSP, so regular, average, even modern app developers can bind keys to the TPM. They can use it. We turned it into kind of this general purpose hardware security device in Windows 8 and tried to extend the reach to virtually anybody writing any application. The other thing that we did was really made an aggressive push to get it into the consumer world. So now instead of for anybody who's played with BitLocker, especially back in the Vista days, dare I say it, it's not exactly the kind of thing you want to give to your mom. And when Windows 8 and then Windows 8.1 came along, you look at the evolution of threats and what people are facing. We needed to be able to get simple, easy, but resilient data protection into the hands of regular consumers, and TPM allowed us to do that. And such, in Windows 8.1, if you have, just regular SOC-based devices, all have encryption that turns on by default. One of the most important elements is that people don't see it. Right? If it gets in a typical consumer's face, they don't know what to do with it. They don't know how to manage it. They shouldn't have to manage it. And TPM has been a really great way for us to take a lot of critical security features that users don't want to have to be involved in managing or understanding, and make those available. So it was a big step forward.
Both of you mentioned more tools, or the introduction of tools to help developers, application developers, write to the TPM in a way that's standard and easy for them to integrate into the work they do daily. Talk just briefly about what some of those tools are. You mentioned the TSS ASP, and you mentioned the work that Intel's doing.
Yeah, so we are working, the TCG itself is working on a new software stack for 2.0. So it's not really a tool, it's a stack, although I guess the stack is a tool. Just like we looked at in 1.2, there are some severe limitations. One of the limitations from a software stack point of view is TSS 1.2 is very complex to use. So given the migration from 1.2 to 2.0, unfortunately we had to break some backward compatibility. As long as we were doing that, let's actually make the software stack easier to write to from a developer's perspective. So one of the things we're doing is the standards organization, TCG, is developing a new set of specifications for this. And in parallel to that, Intel is contributing, as well as other companies, to a open source, although it's not open yet because of TCG confidentiality rules, we have to keep it aligned with the spec. But once the TCG spec is published, these tools will be, the stack itself will be readily available.
Okay, so you said,
so that's the software stack, right? That's not all the other work that they've done to make this thing more usable. That's just like, here's a bunch of APIs.
Right.
There's still more work that has to be done above that.
Right.
That Microsoft has done a really good job of doing.
Okay.
But that work needs to happen as well.
So you say it's going to be easier for developers to work with 2.0 than 1.2.
Yes.
Can you give an example, like what types of things are going to be easier?
Well, I think if you look at the stack itself and how the application stack in TSS 1.2 was done, I mean, I have to admit I was involved in the development of that, and even I don't think to this day I could describe to an engineer and architect how to write a 1.2 TSS app. Where our goal in 2.0 is to be able to say, I don't care about all the policies and the fact that I can make keys expire. I just want a key in the TPM, right? And be able, and much like what Microsoft has done, what he talked about, you built it into the key, KSP. I mean, that's critical to be able to say, okay, I've always created a key this way. It was created in software before. I just want to set this bit. Mm-hmm. I mean, I don't know if it's that, it seems like it's that simple. I just want to be able to set this bit. And then none of my other stuff changes. I just change an attribute. Mm-hmm. And it goes down, and now all of a sudden your key is done inside a TPM. Right? And that's our goal for TSS 2.0, to make it as simple as what they've done.
I have a question. You mentioned part of the process was breaking backwards compatibility, which is a big deal. How did you draw that line, and where did you say, people before this don't get to play anymore because we need to look forward? What were some of the considerations there?
I mean, why did we break backwards compatibility?
No, I understand why, but where did you, how did you figure out where the line would be?
Well, the right line was when we went, really the major event that happened was SHA-1, mm-hmm. right? We had hard-coded SHA-1 into the protocols, right? And we had spent, there's several people in this room, we had spent 2 years trying to find a way to squeeze SHA-256 or anything else into 20 bytes, right, into that protocol, and just couldn't do it. So once you hit that realization, right, once you've broken the API set. Once you've done that, you've now created a waterfall event, and at this point, you start throwing in all the other stuff that generally architects don't get to throw in, mm-hmm. because they're stuck with backward compatibility. Once you've broken that, you're done.
Well, Microsoft got some flack for that when you came out with the issue where people weren't able to parallel boot, right? And so they thought it was you just taking over the world again, and it was a business decision to, more security for the people who bought the machine with Windows license versus, being able to dual boot. Is that still an issue, or figured that out?
Who's asking questions? No,
I'm sorry.
No, I'm just curious. That goes into a different, the other half of, I talked about when we were planning Windows 8, kind of the other half of the realization of we just can't do it in software anymore was the decision to implement UEFI secure boot. So mm-hmm. we used another standard to make sure, I think of it as trust but verify. So we use secure boot to say, hey, try to ensure that a device boots in a trustworthy way, and then use the TPM and attestation to verify that did it actually boot in a trustworthy way. Yes, when we first came out with our plans for secure boot, people looked at that and assumed that we were trying to bind it to Windows, but I think history has kind of proven itself out. There's a number of different Linux distros that have done an admirable job of embracing the spirit of secure boot and making sure that you can dual boot, you can boot Linux systems directly on Windows certified systems. It's not a problem. So
I was just interested in the process of decision making there.
Yeah, it was, believe me, when we first even talked about introducing the feature, it was fairly easy to anticipate some of the feedback we might get, but it was clearly a critical step forward. You look at some of the changes in the threat landscape just in the time since Windows 8 was planned. When we were planning Windows 8, secure boot seemed like a nice thing to have. In hindsight, it seemed like one of those critical things that if we didn't have it, we'd be in a lot of trouble. So. That
actually provides kind of a nice lead into one of the things I wanted to talk about, which is, so we're part of the RSA Conference here, and as you go out into the larger conference, you're going to be hearing a lot about advanced threats, persistent threats, stealthy attacks that lay dormant on networks, and certainly in the headlines we see a lot of stories about that. I've written a lot of stories about those types of attacks, whether it's veterans, the VA administration attack recently, medical device makers, what have you. Is there a place in the discussion about, if you want to call it APT or advanced attacks and advanced threats, is there a place for the TPM for a discussion of using hardware root of trust, TPM technology to provide some kind of bulwark against those types of attacks? I'll toss it to you, Monty. You're the Intel guy.
Okay, sure. So the TPM, as we were talking about before the session, the TPM does a great job of protecting data at rest and attesting to the state of the platform as it booted, right? But when you start looking at advanced threats, right? People often think, okay, well that's going to be a software attack, but the advanced persistent threats are the ones that, hence the P, persistent, persist throughout. And if that gets into the BIOS or that gets into the OS, what you don't want is you reboot that system and you don't have any idea. You make the assumptions about what that system is running, and these systems just continue to run and to continue to infect your systems. So where the TPM does come into play, it wouldn't necessarily prevent the attacks from coming in, right? It's not reaching out and touching software and protecting, and believe me, I saw some articles that said that it did that 5 or 6 years ago. It doesn't do that, right? But what it does do is be able to inform the infrastructure, the IT infrastructure, of what the physical nature of the machine is, as well as the software posture of the machine. Is the BIOS infected? Right. Is it really booting the operating system you thought you loaded on that system? Right. And that's where it can protect the infrastructure.
Right. Gal, your thoughts?
Yeah, so we were talking earlier about some applications for kind of advanced attacks in, let's say, the cloud virtualization layer. And a lot of people talk about, say, cloud security and advanced attacks that don't happen in traditional disk kind of single-tenant hosting environments. And the vast majority of attacks that I've seen on the cloud space are actually things that would have worked perfectly in a traditional hosting environment or an in-sourced enterprise hosting environment with single-tenant, fully controlled by the CIO, because they just barge right through the front door on the application layer and pwn the database through that. So that works whether...
SQL injection.
Right, SQL injection, things like that. So those attacks, the vast majority of the breaches that I've seen that are called cloud breaches, what they're really saying is they're software as a service company that got breached through traditional attacks. Some of the more advanced attacks that people are somewhat concerned about and maybe shouldn't be until they fix their more easily exploited attacks are the various side channel attacks. So I'm sitting on a VM on a disk next to your VM, and I'm somehow telescoping sideways and looking at things and enumerating things. And those are possible. There's some VM escapes that are possible, but those are probably not on your radar or shouldn't be on your radar for priority unless you've solved some of the more easily exploitable threat vectors and problems that we see on a daily basis and that need to be solved by kind of hygiene, if you will.
Dustin, Microsoft probably has the best view of anybody of sort of the global, threat attack space, just given your install base and your visibility and some of the automated tools you have to collect attack data, threat data. Does in Redmond is trusted endpoints equipped with trusted platform modules? As you guys look ahead, do you see those as being more resilient to attack, more able to recover from, withstand, hold off these types of attacks than previous systems?
Well, certainly. I think we view TPM as a critical tool in helping to manage against these types of attacks. I would have a cheekier way of saying, look, the TPM is a way to take the P out of APT, right? In that if you employ attestation, you can at least prove that on the subsequent reboot of that device, you booted good code.
Right.
And that's not going to solve every problem in the world, but that's a critical leg up,
Sure.
right? When you can say, hey, look, BIOS is okay, the kernel's okay, and the first anti-malware or security services that you load on the device are okay, well, hey, you're in a much better position to vouch for the trustworthiness of a given device than if you don't have any of those assurances. And that's why we've been so aggressive about pushing it into all platforms. I mean, a Windows Phone has a TPM 2.0, and it's, you know, it's running BitLocker, and it does all those things, and it's equally capable of providing those same assurances as a PC or a server. And you know, I think as we keep talking about the Internet of Things, proliferation of devices, mobility devices, there's going to be less and less distinction in terms of saying, hey, this is a phone, or this is a PC, or this is a tablet, or this. No, it's a computing device. It accesses critical data, and you have to, from a risk management standpoint, you have to be able to make some kind of a reliable statement about the security state of that device if you're going to keep your job.
Right. I mean, it would seem to be a kind of a thread or a theme at RSA this year too, as focusing on that P piece, on the persistence piece versus the threat piece, right? Because the threats are always there, and we haven't made much progress in getting rid of them. It seems like you're hearing a lot more vendors talking about, like, well, what you really need to do is kind of identify the malicious operation, right? So the way that the attack is able to persist over time, because the longer it's there, the more damaging it becomes. So actually, it would seem to be kind of a good.
Yeah, certainly. You know, in the last panel, someone came up to the microphone and talked about the death of. I think what he meant to say was perimeter-based security. He talked about defense and death, but I think he was meaning perimeter-based security, and that's absolutely true.
Yeah.
We're not going to see a reduction in, I'm going to get myself in trouble for saying this, but we're not going to see a reduction in inbound threats until we remove browsers and mail clients from end-user devices, right? I mean, there will always be a way for stuff to come in. So naturally, we're seeing a fairly rapid evolution from the over-reliance on preventative measures to detection, isolation, and getting optics into what's happening so you can contain and then remove, right? Because the fact is, in a real IT environment, stuff's going to get in. It's going to get in.
Right.
And you know, I think the TPM gives people a gigantic leg up in terms of being able to detect when you know, something other than a momentary, you know, if somebody's just doing one thing at a point in time, that's one thing. But most of the more advanced, I even hate using the word advanced, but the attacks that are more damaging are the ones that hang around and the ones that are able to do a better job of masking their presence on a system. And that's why, you know, things like full-blown attestation become so important.
Okay. I can imagine that there are folks, you know, kind of in the audience saying, look, you know, we're talking about, you know, Windows 8 system, you know, Windows systems and traditional endpoints, you know, with or without TPM. You know, my IT environment is changing radically. So much of what's happening in my organization is happening, you know, in a cloud, either a private cloud or you know, some third-party service provider. You know, I've got increasingly diverse endpoints, whether those are mobile device, tablets, phablets. You know, my data center is totally transformed with virtualization. You know, I mean, and virtual endpoints. How is this technology, which kind of came up in a, you know, single-tenanted environment, relevant to that reality? And it's only going to be more so as I look ahead 5 or 10 years. My environment's going to become even more deperimeterized, more reliant on the cloud, more reliant on virtualization. How does TPM fit into that?
You were looking at him. I didn't hear. I take that first. I'll take it first.
Okay.
Yeah.
So the TCG has been around for a long time. There's over 1 billion devices with a TPM in them, and the perception, I think, it was my perception as well up until I looked into it again last summer for the Analayst paper, that it was really, like you said, built for kind of the enterprise grade laptops, desktops, and in some cases servers and routers to do the kind of DoD or a very high security world, that people that care to really provision, administer this kind of layer, and had the right skill set to do that. But these days, it's really being kind of democratized. So if you look at something, 5 years ago, 4 years ago, 3 years ago, right around the time the iPad was coming through, can't imagine it's only been that long, but the world has changed, and BYOD is here to stay, and it's only going to get more so. Like you said, the browser and the email client is kind of the threat vector for that. And, we're dealing with a browser issue now, the SSL problem from Apple that came out on Friday, and Saturday people figured out it's an OS X issue too. So these things are always going to be with us. Problem is, if someone does an update and the SSL is wrong and someone's intercepting it, putting another piece of code in there, maybe the TPM, if a certain company was a member, would have... I don't sell TCG memberships, by the way, I'm just trolling. That would be good. But you look at also, back to the democratization piece, Chromebooks, I don't sell Google either, but Chromebooks, a couple $100, they have a TPM light inside, if you will, and they do the attestation that the image that was loaded at the manufacturer point is the same image that is loaded afterwards at boot. And so they have a decision point for the machine to figure out if it's in a good state or not. So we're looking at kind of these things getting pushed way beyond the traditional TCG market that I perceived up until last year in terms of very cheap, low-end consumer-grade devices, as well as phones and tablets, not just the little Chromebooks. So I think it's a good thing, and we're seeing some of these attacks come back. The MBR viruses and things like that we saw a long time ago are coming back, targeting the BIOS. So I think it's a positive development that we're pushing these things out. ARM Trust Zone, so back to the company with SSL bug, the iPhone and the little fingerprint recognition. So they have the Trust Zone enclave where they store certain things that are good for people to leverage when they're developing applications. And we'll see more and more of that also, Samsung Knox, things like that. They're starting to leverage the hardware, even in a smartphone. And that used to be, again, only an enterprise-grade, very expensive, top-shelf laptop. So I think it's becoming more ubiquitous. We're not seeing it, but it's still there, and it's working.
So I'll push you on that. You think Apple should be a member of the Trusted Computing Group?
I did not. Well, what are we going to do? I can't help myself. I think that they're obviously leveraging it indirectly through the ARM Trust Zone, but that's not in the laptops, is it? So maybe they should play nice in the sandbox.
I'm not going to ask you for comment.
Thank you.
Do you have anything to add to
that? Well, yeah, I think that, speaking to your comment about, cloud and how, when I mentioned, well, is that the right BIOS that's running? As we start distributing our workload across the network, right? I think you start asking, back in single tenancy, I could go and if I had a contract with somebody, go run my workload someplace that actually ran a physical machine somewhere. If I really wanted to, I could probably go audit this and find out, yes, this machine is actually running my workload in a particular location within a geography, for example.
Geofencing.
Yeah, geofencing, right, yeah. Now, where we have distributed workloads, it's the machine, I work for Intel, so I'll say the machine is no longer the physical platform, right? The machine actually becomes the virtualization layer above the VMM. So, and the problem for single tenancy and being able to answer this question is that workload can now be fairly easily transported across all kinds of physical machines.
Right.
And that might happen several times a day.
Right.
Whereas before it was really hard to do a reinstall and it pretty much stayed there for a while. Now these things are moving all over the place, and I want to be able to audit. I want to be able to understand where this workload is running. Right, and this is where, the term you put, geofencing, at the end of the day, you really need to go down to the hardware and ask the question, who are you and where are you running, right? And this is, again, where, Intel's been participating in, we've got OpenStack, we've been enabling this sort of use model very strongly. We've got a number of presentations this week where we're talking about, how can you use OpenStack to do this kind of thing? How can you use our technology, TXT, which uses a TPM? How can you do that to prove that the software stack that you're running on...
TXT is a trusted execution
trusted execution technology. A particular technology from Intel that uses the TPM to be able to attest to not just the BIOS, but the software that you actually launched, right? So the VMM that launched, for example.
Right.
So you'd be able to ask the question, which VMM is that?
Right.
And I don't have any reliance on a whole bunch of stuff above it to be able to attest to that. And so I think that really one thinks, well, we're getting further away from hardware, but at the end of the day, you really have to have a pipe down to the hardware and be able to test which hardware it is and even where it is.
Okay. I agree with that. There's privacy laws proliferating around the world, the U.S., EU, and elsewhere. And in some countries, Germany is one example, certain types of data about German citizens is not allowed to leave the country. So if that is the kind of data that you're dealing with and you are a German provider of IT services, I see some people nodding, perhaps they're from there. Yes. So the issue is, well, how do I leverage the power of the cloud and those kind of economies while proving to an auditor that someone can't just take this VM with the data on it, snapshot it, and throw it to a data center in Singapore when it's time to auto-scale. So those are things that I think are being addressed, and one of the ways to do that is to bind the virtualization layer to the hardware layer in some magical fashion, and that's already starting to happen. So I think that's a positive sign as well. So people can start working in the cloud while maintaining auditability and visibility into where the workloads, the distributed workloads, as you mentioned, are actually doing the work.
Okay, good. We've got around, I want to leave some time for questions at the end, and we've got about 5 minutes left. I think we're doing well. I think only about 40% of the audience are looking at their mobile device right now. So I mean, by that measure, I think
they're Googling geofencing.
I think we're killing it.
They're looking at where their data is actually running. They're trying to find that quote from their attestation.
They're looking up TXT.
That would be good.
That would be good. Yeah. So last topic that I want to throw out there before we take questions. I was at the Security B-Sides event yesterday, which is kind of a mini-con that runs alongside RSA, and saw a really interesting presentation by two gentlemen from Duo Security, Mark Stanislav and Zach Lanier, talking about Internet of Things technology, and it was a pretty high-level talk. But one of the things they pointed out was this Internet of Things space is thrilling and exciting, but it's also, from a security perspective, a mess. You have tons of sort of bespoke consumer, wired connected consumer products going out there. There are many of them cobbling together, very standard components, system-on-chip components, third-party cloud-based services, and often by novice developers or folks who haven't really worked with embedded or constrained devices before. Authentication, security are very often either shoddily implemented or not implemented at all. And one of the things they were saying is this is a real opportunity to have, to really make use of hardware-based root of trust, some real strong security and reliable security for these devices. How do you migrate this TPM technology, this TPM story, from what it's mostly been about, servers, desktops, laptops, or maybe mobile devices, to this huge kind of dawning world of hundreds of billions of smart devices, constrained devices, embedded devices? I know Microsoft is doing a lot of work in this area, so I'll let Dustin take the lead on that one.
That's a great question. The most important part is not focusing on the TPM itself. It's focusing on what value you're bringing. When you get down to devices at those price points, at thin margins, every piece of engineering that goes into that device has to accrue high value, or it eliminates margins. And I would take it back to things like identity and say, we're very close to that point where hardware binding of identities is going to go from something that people were dreaming about from a long time to something that's just expected. How could you possibly protect the things that are most essential to you with something that could be trivially stolen, copied, logged, whatever. And one of the things that has kind of come along with this rush to mobile is a rush to premium scenarios with mobile, whether it's, hey, I want 4K streaming, or I want first-run movies that are 2 weeks, just 2 weeks in theaters, or things, electronic boarding passes, online banking. I think the most prolific scenario, of course, that we're about to see is the transition of the payment card industry in the U.S. from classic symmetric, non-hardware bound oops to something that's more resilient to skimming, stealing, all those kinds of things. And your credit card is your financial identity. Sure. And we're going to see this very, very rapid transition towards
from magstripe to chip and pin, and then maybe from chip and pin to
hopefully to something better.
Right, yeah.
Well, yes, to something that's asymmetric and hardware bound. And I think you're going to find that that same thing is going to these small devices that are encompassed in the Internet of Things are going to have, in order for them to present value to real people, they're going to need to participate in this identity ecosystem. They're going to need to participate in a payment ecosystem. They're going to need to participate in a private information ecosystem. And in order to do that, they're going to need basic capabilities around hardware binding, attestation in cases, and the TPM is a great solution for that. So,
yeah, and inside TCG, there's an embedded working group. Every platform class has its own little working group. Or big, and in this case, the embedded working group actually of late has been extremely active. And to acknowledge what Dustin said, people can make up their own protocols if they want. In fact, I think this topic came up in the previous discussion. They can make up their own protocols, or they could use what's already been proven and what's already used other places. And there's always a risk of creating your own, of home brewing your own protocol as well. So this group is working on what does it take. Does a small embedded device really need all 103 commands that's in the TPM spec? Probably not. Does it need 24 PCRs? Probably not. Does it need 5 key slots? Probably not. It probably needs 1 key slot, 1 PCR maybe, right? And maybe 3 of the commands. So that's the work that's being done. It's still using TCG protocols, right? But it's defining what's appropriate for that platform. An embedded device is a platform. Right, and I think it's just a matter of looking at all these platforms as being equal participants in the infrastructure, and using the same protocol.
And you were saying earlier that the hardware is going to change. What's important is that the protocols are standard.
What's important is exactly the protocols.
Gal, your thoughts? You're the security, you're the researcher, you're the guy digging into these things.
I think there's a lot of interesting stuff coming out about the medical devices and smart grid meters and other things like that in kind of critical infrastructure. So I'd like to see a little bit more tie-in to those things. I mean, there are obviously TPMs and TPM-like things in various media decoders for many years now. Maybe it's time to put them in medical devices that update their firmware wirelessly, things like that. So.
If you're going to protect satellite TV, maybe protect that.
I'm just saying.
You don't want unauthenticated updates to your pacemaker?
Unsigned, yeah, yes. Right, exactly, right. Which is, scarily enough, not that uncommon these days.
Drama in real life.
Drama in real life,
right.
Yes. Okay. We have a question, yes, and it is question and answer time. So if you've got questions, we've got mics on both sides. Help yourself.
Hey, fellas. So Gull actually said exactly what I was thinking through most of the presentation. He said we will magically bind data to the TPM. So I hate to throw this out there because I'm one of the audience members at Google geofencing. Really cool word, by the way. So you said that I can protect my data using a TPM and make sure that it doesn't go to Singapore. How in the heck does that happen? Please explain your reasoning and tell me how the TPM lets me know where my data is going.
Let me help out my buddy here.
I think that's the vision, and it is starting to happen. There are companies actually, one of them that I'm familiar with is Trapezoid. So they're out of Florida. I mean, they're starting to work in that area. There are some other folks that are working, leveraging the Intel TXT. I'm not an expert in the technical implementations. I think it's a gap that I identified and I'm looking into. So I don't have all the answers. I may have a couple of questions, really. Okay.
Oh, I thought you just said his name, I thought, so I thought you were giving it to him. Oh, I see. Yeah, so Well, one way to do it would be to, and this is one of the things we do in our technology. We have this technology called Reliance Point that can use a TPM as well as OpenStack. Is what you could do is you would encrypt your data, in fact, even the entire VM, right, and protect that data with a TPM, right, and then the keys in the TPM, and you're using TPM protocols to authorize the duplication of that key so that it's not just arbitrary. I would authorize the duplication of that key to only other authorized physical hardware platforms. That's how, and we have a number of products, and I think they're being talked about this week. If you want to visit my colleague Will Arthur back there in the Intel booth, will give you pointers.
A related but not exactly on point thing is the Cloud HSM in Amazon Cloud. So they actually will provision you a SafeNet Luna HSM, and you get to manage the keys. They manage the health of the device and the provisioning of the physical device, and so you're able to do some good work with a physical kind of crypto hardware there. So I think they're back to kind of the larger picture. Is that, like you were saying, we're kind of reaching the end of the utility of software, more software. At some point we have to cut over and say we need some hardware leverage here too. So that's maybe the takeaway for me in any of these discussions.
Yep, go up to the microphone, yeah. There's one right behind you.
Hi, I was wondering about, trusted execution technology. I think that's a very promising technology in this area, and it could also be used for some of the use cases that were asked about binding data to specific applications and stuff like that. And I was wondering, Microsoft, do you have any plans about making it easier to use trusted execution technology in Windows? Because right now it's a very low-level technology that you can only, you have to write your own driver and essentially bypass a lot of things in Windows to use it, but if it would be much easier if it was supported in Windows natively.
By the way, I'll give you the $20 I owe you after the session.
Checks in the mail.
I don't have anything specific to say other than I think if you look at the evolution of our investments, we are continuously pushing code authentication further and further up the stack, and we're just going to keep going, right? I mean, it doesn't, we've made huge steps forward in Windows 8, Windows 8.1, with secure boot, with the end-to-end embracing of the TPM, and we're continuing to push that up the code stack. But naturally, with that comes a lot of interesting challenges around servicing, around a number of ecosystem challenges that we're working on. So it's definitely something we're focused on. But I don't have the $20 answer that says, oh, why yes, in the next version we're doing X. So
but I have the $20 question.
Give the $20 to him.
Yeah.
Okay, thanks.
Good question. Thank you very much. Are there other questions for our panel? Yes.
Oh, we have one.
Oh, one? Okay.
You mentioned TSS version 2.0. When I look at your website, the TCG website, it says 1.2.
Right. Yeah, so yeah.
Repeat the question.
I'll repeat the question.
Okay, you'll repeat the question.
Yeah, I'll repeat. You're asking, you're looking at the public website and you can't see the 2.0. The 2.0 is still under development within TCG. Right, we're showing a demo. Intel's developing source code for one of the layers. And again, we can't make it public yet because it's got to align with the TCG confidentiality rules. And so it's in development. If you're a TCG member, we'd be more than happy to help you. Our goal is to get it out this year.
Yeah, this
year is our goal is to get it out this year. At least one of the layers.
Right out there where they're demonstrating it.
Yeah, just right out there, and talk to Will Arthur, my colleague. We'll be happy to answer any questions for you.
Great, you guys have been great. Are there other questions before we break? Yes. Thank you all very much. You've been a great audience, and I really appreciate it. And thank you to my guests.